All right, here we go. Hi, everyone. Audio might be a tad bit loud. I'm gonna lower that right there. Okay, I think that's pretty good. Hi, welcome back. This is Nick from the Digital Arts Experience. Welcome to the Create and Hang. Very expressive right now. Essentially, what we're doing today is you're gonna hang out with me, and we're gonna continue working on a project that I started yesterday. It's very hard to keep track of which day it is these days. It's a lot of days. But to get you up to speed, essentially I am working on cleaning up this mess behind me. Specifically, I need to build a shelf over here. Not a large one, but one that will be sturdy enough to hold some art supplies and a few other trinkets. And I'm using a mixture of 3D printing to create the sort of framework and some cardboard for some of the shelving. So last time I was here, I sort of came up with a general blueprint and some measurements, planned all that out. Now I'm going to, and you can join me and ask questions as we go. I am going to jump into FreeCAD and start modeling things out. Don't know how far I'm going to get, but we're going to do as much as we can. So let's go ahead and jump into it. All right, so let me open up my project folder here. And oh wow, I spelled dungeon wrong. Dungeon. I don't know. I'll have to fix that later. Let's see here. Where did I put it? Shelving is what I called it. And these are just my measurements from GIMP. So this was just kind of the basic mechanism where we had these pieces that would sort of slot together. And I kind of like it. Again, they're going to be a lot smaller than what they appear to be here. So I think we're going to make that work. So we're going to keep that open. Luckily, I have a multi-display screen, so I can work a little bit more freely. And we're going to go to FreeCAD over here. And I started using FreeCAD a little bit ago. And it's a little weird, but it does work. I think whoever is making this, and I forget the name of the person, or if it's a team, I don't remember. They've done a pretty good job of putting this software together. It's not extremely user-friendly, but it's got a lot of nice features, and it works very well. And I'm quite happy with it. You don't need any subscription. You don't need to provide email. You just download it, which is pretty cool. Now, in this case, we're going to create a new document here, and already we've got the blur of the infinite. So we're going to go ahead and start by creating a body, and we're going to create a sketch. Now, what axis do I want to do this in? Yeah, we'll do this from top view, which is what the YX or XY. Great. All right. Now, I figure what we're going to do first is, rather than actually model this, to get a better sense of the proportions and everything, I'm actually going to create the table first. So that way I can sort of fit things a little bit more. I think that would be a little bit easier for reference too. So let me pull this back over. So since this is a top-down view, we're just going to create the table. And all right, I have to convert this from inches to millimeters. My favorite thing. All right, I got to bring this back over for a second. Sorry, I'm trying to avoid doing a lot of number crunching because I know that's not the best thing in the world to watch, but this is unavoidable in this case. Numbers are important. I gotta say, one of the things I wish, and I realize this is tough to do, is have school projects in mathematics that were a little bit more visual and they gave you stuff to actually handle. I don't think I started to appreciate mathematics until fairly recently, actually, when I actually started needing formulas and things to figure stuff out. I don't know, it's just a thought. I realize it's very hard to do, and you got to learn some specific things first before you do other things. It's tough. But let me see here. So I need 23 and number crunching. Actually, if I remember correctly, 0.65. Nope. 23.625 and another smidge. So another 5. All right, so that is 601.6117 millimeters. So that's the long side here. So 601 1.6117. All right, cool. So we got that length defined. Now we got to do this one, which we'll do that way. And we'll do that one. But anyway, what I was saying was, while I compute this, the world's first computer was named because essentially people didn't want to crunch numbers. Because it's very boring by itself just to do that. So the whole purpose of having an early computer with like a mechanical crank and all that stuff, like no electronics involved, like the first sort of computer, not the computer that I'm using right now, obviously very different. The first computational machine was meant to not have humans crunch stuff. Because back in ye olde days, you had a person called a computer who would just crunch numbers. That was their whole job. And people are like, no, this sucks. So essentially, they just, started coming up with a computer to do that for them so they wouldn't have to. I do find it very interesting where, and again, it's been a while since I've been in school, so they might have changed that, but there are so many, like, they obviously try to have, like, word problems and whatnot, and, like, things with images, but there's just something different about having stuff in your hands and more practical examples. Again, it's not realistic to put that into place for everywhere, there's different situations for everyone, but I do wish we would move toward that a little bit more. So just food for thought sort of thing. And this is 293.68877. Boom. All right. Now we're going to worry about the thickness in just a second, but I want to make sure this is centered on the doohickey here. Though I'm wondering if it makes more sense to constrain it this way. I might do that for right now. Because if I'm going to build this sort of support, I may want the center point around here matching up with the corner of the table. So I'm going to do that for right now, just to constrain it. There we go. And we're going to pad it. And what was the thickness on this bad boy? 3/4 of an inch. So 0.75 of an inch is 19.05 millimeters. That's going down. That's going up. Okay, great. All right. So this, we're going to rename this. So this is our tabletop. So excellent. We have a reference. And let's make sure we save this because I don't want to do that again. Computing sucks. This is why we have calculators. Yes, it's important to know how to add and do all the things, but calculators are useful. You should practice to do it without it if you need to, but nothing wrong with using it. Let me see here. What am I doing? Sorry I went on a math rant for a second. But, it's an interesting topic. What are we doing here? Brain loading. Here we are. We want shelving. I guess we'll call this shelf. All right, cool. So now we got to get back to this sketch. So I don't really have sizes defined here. I think what's going to make sense is to figure out how thick I want these pieces to be, because I think that is going to, one, based on the constraints that don't know where that came from, the constraints that I put in earlier, which, by the way, if you're wondering why my scribbles look like I just, took a pen and just went crazy with it, it's because I was trying to use my tablet and I didn't install the drivers, which I still have to do, so it came out wonky anyway. But I do have a couple constraints. One being that I want to use as little PLA as possible, which that's the material I use for printing. And I want the print to be fairly fast and not take up a lot of time. We also have a limited printing area. So, with that in mind, I think... Oh, I lost all the things went away. All my tabs and whatnot. I need those back. Bring them back. All right, there we go. So, with that said, I need to figure out how thick I want the support pieces to be, because that's going to influence everything else. Now, from my printing experience, I'm going to say that something around like 15 millimeters thick for this should be just fine. 10, I think, might be a little thin, possibly. But I think 15 is a good, solid number. Because if it's 10 by 10, that might snap easily. I don't know. I could print a single corner just to see if I like it or not. I can always update it. I don't know. Maybe we can get away with 10. Because it's going to be like... what did I say? It's going to be 10... And then what's the maximum height? I said about 9 inches. What's, what? Oh, that's 6. That's 6 inches. That's the max my calipers go. Where's the tape measure? So I said the max shelving for each unit would be about 9 inches. You can't really see that from your screen. Sorry. Maybe that'd be all right, actually. You know what? We're gonna risk it. Let's go for 10. We'll print out a single corner in the printing process. But I think that's going to be stable enough because if I print it properly, printer orientation doesn't matter. Let me actually talk about that really quickly. So on a 3D printer, nope, that's a folder. So on a 3D printer, you've got a bed, right? And the printer will move back and forth and slowly build layers up as it goes. Depending on the orientation of the item, so if I printed my support pieces straight up like that, the layer lines would be going across this way, all the way around. That's going to have it it's going to fuse on those layers, versus if I put it down, it's going to have way more, a longer piece of single plastic before it starts creating the middle sections. And that's kind of nice because it's going to be a lot stronger against pulling and pushing in this direction, versus this is actually going to be a little bit weaker because that's where the stress areas are. So if I do that, along with keeping in mind the printer orientation, laying them down flat as much as possible, I think we'll be okay. So, I think we said... I can't remember. What's my maximum build area for Mipusha? I think I said it was 9 inches. Let's see here. I can't remember. Prussia. Is my cube still on here? Yes, it is. Need to clean my desktop. Alright, here we go. Yeah. And just want to see what... So I'd say I probably want to keep it around that size. No more than that. So that is just about 230 millimeters, which how is that in inches? 230. Yeah, it's about 9 inches, so I had that about right. So we'll say 230 is the max height. So how are we going to define this? I think maybe we'll put in a... I think for a start, we're just going to throw in a simple object. Can I do that? Hey, look at that. I added in a cube. Can I transform it? I certainly can. I just need to put in a cube here for reference. And then I want to change its scale. How do we do that? Data, length. Oh, it's already 10 millimeters. Look at that. All right. So the height's going to be 230 millimeters. Okay. Cool. In fact, I could probably just use this instead of creating a sketch or anything. Actually, I can draw on this for reference. We'll do that in a little bit. All right, so that's one of our corner posts there. That seems pretty good. So now I need to go ahead and create a piece that's going to fit around this table. So how would I like to draw that? I think I'm going to... This is a little tricky because in the other sketch, I said I might... Oh, I rotated it, sorry. Oh, no. All right, there we go. Originally, I was thinking of... Which layer was that on? Nope. So I also had the idea of having these pieces that would just slide on the ends. However, I'm wondering if a corner section might be better, but that might increase the size of the table. And I don't know if I want to do that. Plus, it might be a little bit harder to model. I think I want this to be unobtrusive as possible. I don't want to have anything along this gap here because this is where the part where the table actually folds up. So there is a little gap, but I don't want to risk there being any resistance there. I want that to be very easy. So since I can't do corner pieces anyway, because it wouldn't make sense to do it here or here, I think I am going to go with this design. Because otherwise, I would have to model a Boolean and then probably just carve that out for simplicity. So, we are going to stick with this model, not this one. Why didn't that let me draw? I don't know why it switched to white. Excuse me. Sorry. There we go. So, no. We're going to say no to that one. So, in that case, we are going to go ahead, create a new body here. That's just my reference, so let's rename this. What am I calling this? Why is this so hard? Support. Or shelf. Corner support? Question mark. Alright, fine. So we got that there. Now, I think we're going to go ahead and we're going to create a new body. We are going to do that. And let's select this. Create a... Nope, that. Create a sketch. And I want to make this a dependent. She's looking at part of the police handle selections. You want those references? Cancel the command. No, I want it to be dependent. Thank you. So what I'm going to do here is I'm going to go ahead and create a sketch, and then we're going to extrude it. So, so nice when you define everything correctly in those axes. I did it the wrong time the first time, which is okay. All right, we're going to take this little tool. We're going to heat. Herk. Sorry. After a long day, you kind of make your own fun, if you know what I mean. So we're going to do a couple... Nope, not that one. This is going to be straight. That's going to be straight. That's also going to be straight. And all of these boyos... nope, not that one. This one. And that one's going to be straight. Alright, so basically this just kind of constrains it a little bit. Now again, I have to figure out how thick I need this to be. But before I do that, I'm actually going to plug in some tolerances here. So I just need to define... you know what? I'm going to close this real quick. We're going to hide this. Nope. Hide this. I got this. There. Nope. There we go. That's what I wanted. Actually, I might as well define the rest of this. Boop. Okay. So I know that I need this point and this point to be a certain distance away, specifically 0.05 millimeters. So what I'm doing is I'm leaving a little bit of space in the event that the material expands or shrinks a little bit. Turns out because I'm printing with such a large nozzle, it's been pretty forgiving with that. So the tolerances are actually pretty tight. So let's do boop and boop. Oh, no, I want this. That one. I want that one. 0.05. There we go. Cool. All right, so that's just going to make sure that stays a certain distance away. If I need to, I can update it. And what's nice about this is if I change the size of the table, these constraints will stay and everything else will be good to go. So now I just need to figure out how big I actually want this to be. Again, I'm thinking we're going to keep it around 10 millimeters or so. That seems like a decent thickness. Yeah, I don't want this to be too thin, otherwise it's gonna break. So let's make this. Boink. That does seem rather thick, though. Maybe I can... Let's try 8. That seems a little bit better. And we'll just keep that consistent all the way around. Nope, not what I wanted. We will also make this 8 millimeters. And then, all right, I got that defined. I got that defined. 3 degrees of freedom. Where are we? This point? Oh, I see. So we need to define how big this one is. Alrighty. So, well, if I define, so this point needs to be, say, 8 millimeters away. Perfect. 2 degrees of freedom. That one, and probably this. Yeah, okay. What's the distance from... This looks like an additional 10 millimeters here. Or maybe... Hold on. What is this distance over here? Because I want this to be in the corner as much as possible. So... Stop it. Menu. I need you to work. So what is, say... Oh, that's another piece of geometry, though. Can I add that? Well, that... No, it won't allow me. Oh, why, thank you. I don't know if you heard the music, but it says, "You're doing great!" And I was like, all right. I'm doing good. Let's see here. All right, what am I doing here? I don't know. I don't think we need to go too crazy measuring that. So let's come back to that. Is it 26? Let's make it 25. Keep it simple. All right, I need to find this guy here. Also make this... Actually, can I just make this equal? That way I don't have to... Boom. So that way, anytime I change this measurement, that's going to go on over here. See, now I'm thinking. All right, so we have that roughly defined. So I can close this. Turn that off. Turn this on. And now we're going to go ahead and pad it. Nope, other way. Ah, I got an itchy shoulder. Hold on. Okay. All right, we're good. All right, so let's maybe double it. So if it's 20 millimeters, I have this being 10. We could put 5 millimeters on either side. How thick is 5 millimeters for reference? That's not bad. I'd be okay with that. Okay, cool. So I just got to make sure that this is in the correct reference spot here. The other thing I have to think about is I could probably just make a hole here so that this is actually flush on the table. It just fits through this piece here. So how does one go about doing so? I say, good sir, how does one might accomplish such a feat? I don't know why we went back to 19... No, not 60. Not 70. 1920s, I want to say. I think that's a 1920s voice. Let's see here. Had to think about that for a minute. So let me see if I can move this guy. Let's do a transform. In fact, what are the... Where's it? Nope. Stop it. I'm gonna... No. Stop it. Alright, where are you located right now? Translation. Let's go to top view. Oh, did I just move it correctly? Oh, I probably can't even see it because it's all one piece. Huh. Hold on, I have to math. Alright, so I have a thing that's 20 millimeters long. I have a thing that is flush, that is 10 millimeters, so roughly half. How many units do I need to move it over to get it in the center? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would stand to reason if it's 10 units long, the midway point would be 5 in. So to get it center, I would need to move it 5 units down. It looks like I did. Alright, apparently I eyeballed it perfectly. Mic drop. Or marker drop. Alright, cool. Oh, lost my space there. Okay, awesome. So let's come over here. So I think for right now, I also have to plan for tolerance. So let's hide. Nope, not that one. We're gonna hide this guy for a second. We're gonna draw a sketch on top of here. Ooh, that's no longer center. That's okay. We'll work with it. Alright, so we know that we want this to be... So not 10 millimeters. We want it to be... We'll plan for tolerance the other, so we'll say 10.05 millimeters. And this is going... Stop it. These guys are going to be equal. This is also... Wrong direction, though. This is also going to be 10.05 millimeters. And that should pretty much constrain it that way. We just got to get it in the center. So if my math is correct, it should be 5 units from the edge in either direction. So let's just add this in as a reference point. Listen, computer. Alright, that doesn't seem right. No, we got a whole distance over here. This is... Oh, again, this is a little bit bigger, but it shouldn't be that far off. Is my math wrong? No. What am I doing wrong here? Hold on. We gotta draw this out, do this together. I gotta put my brain to the metal here. If there's much of a brain left, I swear, I'm eating a brownie after this. I worked hard today, and I deserve a gosh darn brownie. Alright, so let's see here. So we have a thing. Alright. It is 20 units across. So that's at 10. This is 20. And we'll say that for reference, this is 0. Originally, this... So we want this in the middle. This is 10 units across, right? So it's 5 in this direction. This should be 5. This should be 15. So it should be 5, 15, and then 20. So it should be 5 millimeters from the edge. What am I missing here? Is it just from the other direction? That doesn't seem right. Unless this is not... Oh, wait a second. This is 8 on the bottom. That's right. And then how far was it padded out? I'm thinking that's a square. This is not a square. That's my fault. Tabletop. What's the sketch here? Nope. Not what I wanted. What am I... Let me look at the original. No, I want the original sketch. Thank you. So, oh, this is 25 millimeters across. All right, so that's one problem. And then if I remember correctly, how far did we pad it out? 20. So the top here is actually 20 by 25. Aha. All right, different numbers. Do. Where's my eraser? Different numbers, boys and girls. We had it wrong. So it was 25 in this direction and 20 over here. All right, so if it's 20 all the way across, we want the distance. So this would be 10 would be halfway up. This is 10 units long, so if this is the center point, that's 5 down. So it'd be another... Wait. It's 10 units and then 5 and 5, so that should be 20. So it should still be 5 units from this way? Hold the phone, folks. That might be right for this direction. Just about. Okay, that looks correct. So it's just this direction that I mucked up on. All right, so this way it's 25. So this is 25. Oh, midpoint's going to be weird. 25 divided by 2. It's 12.5. So it's going to be 12.5 in the center. And then 5. Oh, math. 5 that way is 17.5. I'll just do it from the other side. And then so then 25. 25 minus 17.5. So this distance here should be 7.5. If me maths are correct. Same for the back area if my math is accurate. Which wouldn't put it past me for it not to be. Yeah, that looks correct. Hey, we did a thing. I'm no rocket scientist. I will take my victories where I can. All right, cool. So we got that. And we're going to turn this into a pocket. No. Oh, I don't have it. It's not the active body. We'll make it the active body. There we go. We just want this to go through all. There we go. So now we have a corner support. Boom shakalaka. I don't remember what that's from. I feel like that might have been from... Oh, what was that movie with Shaq and he was a genie in a boombox? Yeah, that was a weird film. I seem to remember liking it, and there was something to do with a milkshake in there. I don't remember. It was a long time. I think it was a Disney film. Oh, actually, I'm going to take that back. I don't want this to go through all. I think I've said it before, and I'm going to say it up. I'll say it again. I think that... Did that work? Up to face? No. Dimension. Ah, music. Oh, alright, we're fine. What, this is 8? Actually, how thick is the thing? Tis 8 millimeters, sir. So we're gonna come back over here. No. No. I want the pocket. 8 millimeters. Oh, interesting. That's gonna leave like a little bit of lip on the inside here. Is that gonna do anything? Nah, I think I'd rather have it at 9 just to make sure there isn't like a really thin face over here for 3D printing purposes. So long as that fits snug over here, Should be fine. Is that the corner of the table? Maybe I should just move that over to offset it. Yeah, let's actually do that. So let's add... Let's come back over to the pocket here. No. No, that's the right one. We're going to offset this by... We're going to move it forward just a smidgen. Just to see if that gets rid of that. Yeah, okay, there we go. Probably overdid it by a little bit, but that's okay. Alright, so we have our first part. That's one corner. And what's nice is, because we designed it this way, we can just duplicate that, move it on the end, and just rotate it to fit what we need. Or we could do it on the ends. Works all the way around. Cool. Yay! We did a thing. I need one of those noise makers. Does it just... Wait, I'm on the internet. We can find one. Noise maker. No, not how to make a noise maker. I need the actual sound. This is important. Party horn noise maker sound effects. Let's go for it. I don't know what it was saying in the background, but you know what? All the way. Alright, let's see here. Getting back to the business at hand. Alright, so we've got that. Now we need to do a thing. So I guess we need to... So we've got that. Right? It's a little offset. That's okay. Or somehow it's fitting just right. Question mark? Very weird. I think I'm just going to turn that off. I'm actually going to take... I'm going to grab this sketch. And, oh, music go bye-bye. There we go. And what am I got here? Blah, 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 blah. So we're gonna... Which sketch am I looking for? I think it's the... Nope, not that one. That's the one I want. We're gonna go ahead and create another body. Where? It's under part design. There we go. Create body. And we're gonna create a sketch on top of here. Bloop. And we're going to create another thing. And this one, we're going to make 10 millimeters. This and this are going to be equal. This is also going to be 10 millimeters. And that by default will lock this in because they are all parallel. Oh. Sorry. That snuck up on me. Okay. Let me just see something. This should not be matching up. Should be a little bit smaller. Yeah, because there's going to be a little bit of a tolerance difference here and there. So I'm actually just going to make sure that... Let me come out of here for a second. Oh, I'm wondering if I should have... No, we can pad it in two directions, I think. Let me double check. Pad... Oh, yeah, we can do 2 dimensions. Great. We'll do that in a second. I'm going to turn off the rest of this stuff for the moment. And we're going to go back to the sketch. Move that over here. Just gonna get some references real fast. And I need you to come back over here. And we need you to be 0.05 millimeters away from that spot. And from here to here, 0.05 millimeters. That should constrain it. So why is this lining up perfectly over here? That should not be the case. Huh. Interesting. Hide that for a second. Nope, not that one. I want the bottom one. So I already made this 10.05 to make the hole a little bit bigger than the actual parts. So the tolerances should already be in there. So what's going on? Skip over the song that I really don't like. It's like the one song in that whole thing that I just do not enjoy. Let me see here. So what's going on with our tolerances over here? Because this should be a little bit larger in all directions. Did I type in something wrong? I would not put it past myself. Oh, where did my sketch go? Oh, you need to turn this on. That would help. Don't know why that resets. Unless this is 0.05 millimeters. Yeah, that's correct. 50 UM. Am I doing this the wrong way? Let me try something real quick. Because this is constrained. I can move this wherever I need to. Hold on. I want to see something. Let me move this out of the way. What? How thick is this? 10.05. Okay. Hello. Okay, that's correct. This is 10 millimeters. And this is 10 millimeters. So, what gives? I should be able to fit that in there. Have I been doing this wrong? Again, I would not be surprised. Let me just see something. I think that gives me the same result, though. See, this doesn't make sense, right? So if I have an area of 10.5 around here, and I make something a little bit smaller, oh, you know what? I think I was doing this the wrong way. So let me change my sketch over here. Oh, nope, that is not the eraser tool. Whoop, whoop, whoop. So if I have an object, right? And I've got a hole. I'm just gonna draw this with straights because it's gonna be a lot easier. Well, hold on. Let me see something. So I've got my tolerance test over here, which I printed off screen. Where's my 0.05? That's 0.15. 0.05. So we look at this. This is a tolerance test I did with the exact same example, and 0.05 is super tight. Let me just actually open up the file where I did my tolerance test. Because something is not adding up. I thought maybe because I was constraining it by 0.05 in both sections, it was actually lowering it to a tolerance of 0.1 on all sides. Because basically what I'm telling it to do here is if I'm taking out the 0.5 on one section, then it's going to match up on the 10. So my tolerance test might have actually been set up incorrectly, which is annoying. It won't allow me to do that in here? File, how about now? No? Does it not want me to be in sketch mode? Yeah, it doesn't want me to be in sketch mode. So let me come out to exhaust port tolerance test. So let me look at this really quickly. No, you're not gonna let me do that? Why, is it permanent because of the Boolean? Well, I'll turn that off for a minute. What, you can't go back and adjust it? What nonsense is this? Meh. I don't like it. Turn this off. Really? Why can't I get to that anymore? Start part? What are you, crazy? I just delete the Boolean? Is that gonna allow me to do things? I was hoping to come back into this file and see my original measurements, but alright, so this tolerance test I made may not be totally accurate because my original thought process was when I was making the hole here, I basically had a 1-to-1 part and then I would slowly scale it back. The problem is, now that I'm thinking about it, let's just say for simple math, if I expand the hole out by 1 millimeter over here and 1 millimeter over here, then I'm not really expanding it out by 1 millimeter. I'm actually expanding it out by 2 all the way across the board. The tolerance is 2 because that's the amount that I've expanded it out by. So in our case, for me to line, it's not that my tolerance is wrong per se, but the math is slightly off. Nope. I guess it defines on how you want to count tolerance. In my case, the way that I modeled it, it's 0.05 away from all edges. So a 1 millimeter general like scaling, I guess would be the term for it. So I have to keep that in mind when I do my stuff. That when I did all these tolerance tests, it was on each side, not just the one. So let me come back over here. This is why this is off. So so instead of, no, I don't want that one. It was that one I was working on. Corner. Nope. There we go. Back to the sketch. So in order for this to be equal, I need to cut this number in half. Just so it's centered. And that should match up now. Yes. Okay. Cool, cool, cool. So now we're going to go ahead and pad this. Make a dependent copy. We want this in 2 dimensions. I believe we want this to be 8 millimeters down. And I wanted it to be... How many millimeters? 230. So 230 minus 8 should be 222. Yes. Excuse me. Unsupported shape type. 'Tis a square. Corner support. Heh. Oh, did I have the wrong thing selected? Oh, sorry. Nope. No, that's the right one. Dependent copy. What do you mean sub-shape type? What do you mean? Because I have a reference point. Is that reference sketch? What is this? I don't remember making this. Hold the phone. We got to investigate for a minute. All right, that's off. Oh, okay, whoa. All right, so that's just on that. What is this? Can I just delete this? Where did these come from? I don't need those. I only need the one reference pad for this piece, because I drew it over here. Why did those pop up? Alright, hold on. Dependent copy. Those are being generated from that for some reason. So let's get rid of this. Did I draw the sketch on the wrong thing? Is that what happened? That should just be a reference pocket. Curious. The mysteries of CAD ever continue onward. That should be fine. We got no issues with the constraints. Those are just construction lines. Huh. Oh, is this not that's not the current body? Is that what it is? Please tell me that's what it is. Huzzah! Okay. Like I said, take your victories where you can get them. 2 dimensions. I want this to be 8 millimeters down. Whoa, hold your horses there, bud. And then, ready for this? 222. And if I hide this, that should still match. Could we fit it all, please? Zoom to fit. Oh, barely. Just barely. I wonder what was off. Huh. Weird. Well, that's alright. Because it's gonna... The height's gonna change anyway. I'm not super concerned about this being off by a smidgen, though I am... my curiosity is piqued as to why. I don't know why the accents are coming out right now. Let me see here. Sketch. So that's just that. That's fine. Is it because the corner shelf is a different size than I would think? Corner support. Turn you back on. Oh, hello. What is this? Oh, what happened here? Whoa, whoa, hold on here. Huh. It went the wrong direction. Can I just make this negative? Nope. Doesn't like that. Hold on. Somehow this got mucked up. I'm going to delete that. 'Cause this needs to be over here. The top seems to be okay. Don't know where that went wrong. So from here to here. That was really weird. And then because... What is this distance here? That's 8 millimeters, so I need to make it 8.05 millimeters to make it flush. That's what it is, because I'm taking into account I mean, technically I don't. That's just for the tolerance. That is still going to be straight. So what I could do in the pad is take the top down by 0.05, so 1.05, and make this 8.05. Because then basically if I take the 0.5 from here, put it up there, that gets it back up to the 222. So that should now be flush. Assuming I can do the right thing. Ha-ha! Love it when a plan comes together. It's not... it's meh. Why is it off of the table? Again, it probably has to do with the actual corner support here. Oh, you know what? It's the placement of the top up here. Oh, it's so close. I don't want to go crazy. I've done enough math there. I'm sure I could figure out why that's going on. This is a cardboard shelf. Let's not tear our hair out over it. Okay. But at least I know I can figure it out because I'm smart. I am smart. Thank you very much. And we're going to save that. All right, so we've got 2 components built right now. I think what we're going to do is in the next video, we're going to go ahead and start figuring out the parts that need to sort of fit and snap together to get the support pieces in place. I think we're going to start with maybe figuring out the parts that go across here. And we'll figure that out. I'm thinking, though, because this is... How long is this piece here? Hold on. Let's just do a little bit of prep work for next week. Next week? I'm probably going to be streaming this again at 2 o'clock your time. So... Probably just going to continue on with this and just finish it up and then get back to the cool stuff I usually do. Not that this isn't cool, but it's a different flavor. Yada, 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 yada. Oh, I have a ruler here. Does that measure distance? That's not what I wanted at all. Ruler, you have failed me. I'm saddened. Let's go to part. I think there is a more... yes. Can you do that point to that point? Wait, didn't I write this stuff down? It's in the sketch. What am I doing? Why? No. Clear all. Get out of here. Shoo. Tabletop. Sketch. No, no, no. Close. Thank you. Sketch. 29. Okay, so 293.689. So that's about 11.5 inches across that away. And I think even on a good day, I don't think I can print that all the way. Let's turn this off. Yes, fine. So, will you let me scale it? Hold on. So even if I make this, say, boop, 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 300. Barely, but I'm going to have some bigger pieces here. So I think for safety's sake, what we're going to do is we're going to print some parts that will fit on here and then extend out to create the pieces that we need. So basically, there's going to be... Sorry. Let me come back over to the drawings. So I think we're going to go over with this design over here, where we're going to have the parts. Basically, you'll have to put two pieces together on a rod and then have it slide down to connect all the parts together. So I think we're going to do that, but we'll do that in another episode. So again, my name is Nick. I hope you enjoyed this sort of CAD experience here. Again, sort of just taking this step by step and working on getting the workspace optimized, because that's going to allow me to do more cool things. I already have optimized my area for SLA and FDM printing, so I can do that a lot more easily. I ordered a webcam, so hopefully I can actually show you guys when the prints are going. I'm going to have some more videos coming out very soon, I hope, about like some of the printing stuff that I'm doing and show you the actual parts. Unfortunately, my webcam is like optimized and I can't just move it back and forth. It's a big pain in the tush. So hopefully I'm going to do that. If you like all the videos that we're doing, you want to learn from either me or one of our instructors about how to do either CAD, drawing, or any of that stuff, feel free to reach out to us. We're more than happy to teach this stuff and just learn and try out all kinds of cool things. Doesn't matter what the project is. So feel free to reach us. Our contact info is in the thing below. Any class at all, let us know. We can set something up. Again, my name is Nick, and I'll see you a little bit later today, all right? And yeah, have a good day, guys. Bye.